Hello friends and greetings for the day. Welcome back to another tutorial on ISTQB Test Automation Engineer certification, where we are talking about the discussion on several topics related to this particular examination. As a part of this particular tutorial, we are getting started with the chapter 2, which is talking about preparing for the test automation. And as a part of this segment, we are starting with the first part of it, which is 2.1, understand the configurations of an infrastructure to enable test automation. In order to get started, the very first topic we have for you is, of course, the configuration needs for the implementation of test automation. At this point, we want you to understand that setting up test automation within an organization or a project is not that simple, like getting the tool, procuring it, installing it, and the job is over. Certainly, we may have to set up a lot in order to make that test tool work, because it may require a particular set of configuration and the required infrastructure to support it. Sometimes additional softwares are also required to install in order to make them work or perform them without any kind of coexistence issues, because sometimes they may contradict with some of your other existing applications or may not perform well just because some of the components are missing. So there could be a lot of other softwares and additional libraries which might be required to be available in order to make them work. And you can relate this example very much to Selenium. As you can understand, it's just having a particular editor or IDE may not make your Selenium work. You would need libraries and packages to execute a particular script. Sometimes these packages may not be understood. You may have to have the right set of libraries to be imported and linked to that particular project folder. So there might be different set of activities which might be invited for different types of tool. And that is how crucial it is to understand what kind of configuration is required to be set up in order to make a test automation tool work. And in this tutorial, we are talking about the same. So let's continue further. Of course, when it comes to testability of the SUT, be it about availability of the software interfaces that support testing or to enable control and observability, it should be designed and implemented in parallel with the design and implementation of other features of the SUT. Certainly, you don't have to wait for SUT to be implemented. Here, SUT is referred to as system under test. So we don't wait for the code to get completed and deployed to us, and then we start working on preparing these infrastructure or environment which we need for it. We can parallelly get started, and that's the best time to do it because we know the infrastructure, what we need to host this particular tool. Also to add, of course, this work is generally performed by the software architect, as testability is non-functional requirement of the system, and often with the involvement of the test automation engineers to identify the specific areas where improvements can be made. So we may not be just alone in order to set up and design this infrastructure or environment which is needed to host. So when it comes to preparing for the test automation, I may have some direct involvement from the architect in order to support us with what is the setup required for the same. Now, further to add, we are talking about things like for better testability of the SUT, there are different solutions that can be utilized which have different configuration needs. For example, when we talk about accessibility identifiers, the different development frameworks can generate these identifiers automatically, or the developers can set them manually as well. Also, system environment variables, certain applications parameter can be changed to enable easier testing through administration. And same way when it comes to deployment variables, similar to system variables, but can be set before starting the deployment. So right from these examples, what we just understood is that for having different parameters to be dealt with, we may have different point of time to do this, or certainly may have different steps to be performed by different people in order to make this happen. So it's not that the testing team alone can handle everything what we need to do, but we may have involvement and participation of multiple other stakeholders to contribute to implementing this environment. Well, further to add on this particular thing, we have the next topic where we are talking about the configuration needs for the implementation of test automation, where we are exactly referring to the details of those information which we just discussed a moment back. And here we are just trying to discuss and deep dive into these keywords, that is, what is observability, controllability, and architecture transparency. So designing for testability of a SUT consists of following aspect. Number one, observability. Here, observability simply means the SUT needs to provide interfaces that give insight into the SUT, whereas test cases that can then use these interfaces to determine whether the actual results equal the expected. Observability, in simple words, I can relate it easily to that of monitoring or capturing the property attributes which can retrieve the information from the SUT, which is the application. Now, as we talk about interacting with the applications, we try to collect the runtime data and information from these executions. And this observability is more about getting interacted with those interfaces which are visible to the automation testing tool and can help us to retrieve those properties like name, value, which contains the attribute which we want to measure or compare with that of the expected result. So as a part of the script, we can give the expected result, and during the runtime, we'll capture the arrow property of that particular object with the actual result, and doing a simple assert can help us to quickly validate them and come back with the conclusion that what exactly it is. So we must design the architecture or design the steps which should be able to perform this observability. Or in fact, we can even relate this to the monitoring aspect of any tool. At the end of the execution, if your tool is capable of producing results, that means during the execution, the tool had observability on multiple parameters, which was able to determine the outcome of the test in form of transparency or in terms of reflecting into graphs and data tables, which could be of great help. The second important factor we have is controllability. The SUT needs to provide interfaces that can be used to perform actions on the SUT. This can be UI element, function calls, communication elements, or electronic signals for physical or logical switches on the different environment variable. Now again, I don't want to talk only particularly about performing a script execution. We also want to discuss in the fact that the environment should be created in such a way that it is controllable by human beings. That means suggesting what kind of execution should happen at what point of time. So to make it at layman level, I would say that having an if-else statement could be again an example of controllability. That means based on certain condition, I want to perform a particular piece of code or execution. So it's not necessary that if you have written a big test, no matter modular, but should be executed all together. We can define the controllability factor here and shall look forward to see if we can really determine what exactly could be the ways of executing them. So I may have conditions, prerequisites defined, and based on fulfillment of that, I can determine what part of the test script to be executed. And that's where the controllability comes. And same way, they have given the example to you about some of the examples from the automotive environment, like when it comes to communication elements like TCP, IP, etc., these internet protocols, or if you talk about USB protocols, then I may define the signals, the switches, the voltages which we can pass based on certain interval of time, or maybe when based on a particular condition, just like how exactly your sensors in the automobiles work in terms of performing an activity without your interference. So that's the controllability part. So environments must be controllable. On the other side, of course, the third element is architecture transparency, which certainly talks about the documentation of an architecture needs to provide clear, understandable components and interfaces that give observability and controllability at all test levels and foster quality. So in simple word, I cannot do observability and I cannot have controllability in an environment until unless I have architecture transparency. If the code is written in a way that the system acts as a black box to us, it might be very complicated for us to identify those attributes or detect those attributes like properties of the object which are important for us to interact with for the running of automation scripts. So having an architecture being transparently given to us, we would have visibility to all this information and we can draft and prepare our test automation more efficiently than that of struggling to find the properties of the attributes. So that's what is making very clear that what exactly is the need of implementations when it comes to the test automation. Moving on to the next topic we have for you in the same segment is talking about how we can leverage the test automation within different environments. You don't need me to talk about this. Of course, you know that we have different stage environments where we talk about some of the standard naming conventions like dev, QA, SIT, UAT, sometimes pre-prod, and prod as well. So it's not that it is just, one single environment is used for different purposes. You may have different environments for different levels of testing, and each one of them can be configured differently and maybe for different type of executions. So in this topic, we are trying to just discuss the same. So let's quickly look into that. So when it comes to leveraging the test automation within different environments, different types of automated tests can be executed in different environments. So these different environments can differ between projects and methodologies as well, and most projects have one or more environment to utilize for testing. From a technical point of view, this environment can be created from containers, virtualization softwares, or using any other approaches. So right here, we are just telling you that, however, we are going to discuss some of the environments as a part of this particular syllabus and this particular topic. But in your organization, your product and project needs may determine different set of environments. So it's not that we are contradicting and saying that these are the only environments. You may have different names, different types of environments for different purposes, and we are just giving you something which is quite generic and easy to understand that what could be the use of different environments and how exactly you can be using these environments for performing different executions. To start with, the very first one we have is local development environment. It says a local development environment is where software is initially created and components are tested with automation to verify functional suitability. Several test types can occur in the local development environment, including component testing, GUI testing, and application programming interface testing. It is also important to note that by using an integrated development environment on the given computer, white box testing can be performed to identify poor coding and quality problems as soon as possible. I would say this is something as an environment which we refer to as dev, as in when a developer completes writing a code, they need to perform a quick check initially to make sure that the code is stabilized and can be used for any further purposes. At the same time, when we talk about conducting unit testing, the local development environment where the developer is developing the application, this environment could be very useful for performing the component test, which is unit testing, and things like GUI testing, also the API testing. But again, in the real practices, we would say that, hey, we may have a dedicated QA environment to conduct integration testing or API testing. So it might not be so, coinciding with the same thing that what the syllabus is trying to say is so much practical. But indeed, why not? If required, they can do an initial check from their side that whether we can perform these things, they are working fine, whether the data can be passed on from this particular program or not. And then we can further do it from a UI point of view or using a postman, using the white box techniques to perform the required test as well. Okay, so one is from the development point of view that developers are performing this. And then when it comes to us, we will be performing it differently. Okay, so that's the point being made here, that the first development environment can be used for all these purposes, and preferably we use the white box test techniques to do these executions. The next important environment we have for you is the build environment. And the build environment is quite pretty much same to that of development, but its main purpose is to build the software and execute test that checks the correctness of the resulting built-in DevOps ecosystem. This environment can either be local development environment or a continuous integration, continuous delivery, which is CI/CD agent, where low-level test that includes component and component integration test and static analysis can be performed without actual deployment to any other environment. So first of all, they're saying that this option, this particular environment is optional if you have local development environment, because if I connect this dot to CI/CD pipelines, we know that a developer is using a development environment to write the code. And as and when they check in, when it comes to the understanding of CI/CD, we start with the build verification, which is the stability check by performing the basic root level executions, and then certainly gets performed with static analysis. Then we may have our integration test being performed. Then we may have our system tests and regression tests being executed. So CI/CD can have integrated tool chains to perform these activities. But these are all automatically triggered. But the manual process would be the developer writing the code and then triggering or checking into the repository. And as and when this check-in event happens, it triggers my all other test cases. So they are also agreeing to this fact at this point of time that if you are not using CI/CD, then this particular environment can still be done, or the activities of this environment can be done in local development environment itself. So you don't need a separate environment for that. But if you have CI/CD, your first environment would be called as the build environment. The next environment we have for you is, of course, the integration environment. And here, as the name suggests, we would be performing the system integration test here. So yes, it can be referred to as SIT, and build environment can be referred to as QA, what we have. And this would pretty much perform those activities which are related to the next levels. So yes, after performing the low-level testing and static analysis, the next stage is a system integration environment. Here, the release candidate of SUT is present, that is fully integrated with other systems that can be tested. In this environment, a fully automated test suite, either UI test or API test, can also be executed. Also in this environment, there is no white box testing, only black box testing. And it is important to note that this is the first environment where monitoring should be present to see what happens in the background during the use of SUT to enable efficient investigation of defects and failure. So indeed, quite relating to SIT, and as we understand the fundamentals of SIT, it is going to be systems of systems. And as we talk about performing these tests are generally performed using the approach of black box test techniques. However, this environment will only be used once we have stable results from the previous environments, and they may be used to perform all functional tests and at the same time the additional API test. But as we would be performing on the front end, that is black box testing, we might need additional monitors or tools which can capture the matrices during the runtime, which would enable us to identify the failures or any kind of issues during the execution. In simple words, it is very difficult to conclude what went wrong when an automation test fails in a bigger piece of work, right? So it might be possible that your data is wrong, it might be possible that your script has an anomaly, or it can also be possible that you went wrong with the flow of execution, or it might be an application issue as well. But it's not necessary that by default a failure results into detection of defect. So we must spend our time understanding the same and then conclude on it. Finally, we do have another set of environments. So we do call it as pre-prod environment, which is certainly to perform the remaining test, which we can easily correlate to that of acceptance, that is about UAT. So a pre-production environment is used mostly to assess non-functional quality characteristics. Although non-functional tests can be performed in any environment, there is extra focus on pre-production because it resembles production as closely as possible. Often user acceptance tests can be performed by the business stakeholder to verify the final product, and it is possible to execute the existing automated test suites here as well if necessary. This environment is also monitored. So right from the QA part, you will have monitoring in place. Most important thing, pre-prod is being referred to as UAT here, and UAT is the place where we let the business perform the required executions. Certainly you may have automation test which can be executed here as well. So you may hand over these deliverable to the business in case you want to use it, or they can have their own set of tests, can be manual as well. Plus, this environment is just not limited to these UAT or acceptance tests to be performed. You may have a lot of other non-functional which are in scope of the organization to be performed right here. At the same time, if you look at it once again, it says that these are generally very close to that of production, so may perform a lot of other real-time testing. So real-time testing simply means that those tests which might be difficult to be performed in early stages can be performed here. For example, if I want to really test if the sensor behaves well in different weather conditions, I cannot do that in the unit level, I cannot do that in the integration level, and I cannot do that in the system level. Once system integration testing happens, that is with the confined environment, I see the sensor is detecting the different voltages and accordingly creating the act of applying the brakes or stopping the car. And then when I have satisfactory result, I take this car to different weather conditions to check in the real world that whether these will be working. Now, as you understand, having a real car testing this particular feature of sensor could be very expensive. I do not try to do this kind of early, because that will be early cost in the projects. So we try to push things a little later and try to do it in the most close to the production environment so that only the limited tests can be performed there. So yes, we can push those tests only which might not be of any kind of meaning if we perform them earlier. So we should be doing it later. And finally, the last environment is production environment. And production environment can be used to assess functional and non-functional quality characteristics in real time while user interact with deployed system with monitoring and certain best practices that enable testing in production. Example, canary release, blue or green deployment, and A or B testing. So again, these are some of the examples, but general understanding says that we do not do any kind of testing in production. But however, there are many domains which invites you to perform testing in production as well. For example, mobile application, once you launch them onto Google Play Store or App Store, you are required to perform a test once it is finally listed on the App Store or Google Play Store. So it's not that you don't do testing in production, but it's not testing as such. It's more about a assurance that the things are continuing to work fine when they are released in the real world, because you may have issues in the live and you may have to make sure that you deal with them before users can find them, right? So exactly, there could be many purposes of these production environment to be used and conducting the required amount of test. Well, it might went a little longer, but yet in a flow, it would make more sense. So that's why I tried covering them together. So that's all from this particular tutorial team. Should you have anything else, feel free to comment below. I'm always there to address your queries and answer them well. Till then, keep learning, keep exploring, keep understanding the context. Thanks for watching the video team, and happy learning.